The definition of system is the foundation of systems thinking. The difficulty is that if you ask a dozen systems thinkers for a definition of system, you probably get about 25 different answers, which really confuses the situation and makes it very difficult for new people attempting to understand the domain of knowledge. The definition of system that I came across, that I became extremely comfortable with because of its simplicity and precise nature, is one from Ludwig von Bertalanffy, who is considered by most to be the father of modern systems theory. The definition is: a system is an entity that maintains its existence through the mutual interaction of its parts. And the key part of this is that it has to do with interaction of parts and maintaining its existence, so that in its simplest form you might consider two entities interacting with each other, and through the nature of that interaction, it maintains its identity. The identity being, systems exert a characteristic called emergence, in that because of that interaction, there are characteristics of the system that result from that interaction that you can't find in any of the parts. And I'll make this a little bit more explicit when I talk about some examples. So that an alternative definition of a system that works real well is: a system exhibits characteristics not produced by any subset of its parts. In other words, the system as a whole has some attributes about it that you cannot find as attributes to any of its parts. So this gives us two definitions of a system: one from the inside out, in that it maintains its existence through the interaction of its parts; the alternative being that from the outside in, that the whole has characteristics not exhibited by any of its parts, and if you take it apart, you lose the essence of those characteristics. Now, there's also an aspect of systems. If you look at a component and its interaction or its influence on another component, one has to take into consideration the result or the implication of that interaction, and the way that component then interacts back with the initial component is referred to as feedback. If you started here and thought about the way that this element interacts with A, then the way that it interacted as a result back to B would be defined as feedback. So what's feedback depends upon where you start from and what's coming back as a result of the interaction. So feedback can be either reinforcing or balancing, depending upon the nature of what it influences, so that if A influences B and the feedback influences more of the same action, we would call it reinforcing or positive feedback. If A influenced B and the result of that was to discourage more of the same action, you would call it balancing or negative feedback. Negative not being bad, simply negative in terms of it diminishing or the likelihood of more of the same action. And as to where one defines the boundary is an artificial construct of the observer or the group of observers considering this which they determine to be the system. So there are people who will talk about the fact that systems don't exist. Well, they don't. Stuff exists, though what one portrays or labels as a system is based upon where one chooses to define the boundary. So if I take these two elements and draw a boundary around them, I've established this as the system based upon where I decided to draw the boundary, and that system is likely to have an interaction with things outside of it, which are termed the environment. So if someone says something to you about the system, the first question that you probably should ask is for clarification as to just what it is that they mean as, or what their perception of the system is, so that the two of you are in fact on the same wavelength. I've participated in numerous discussions that went nowhere because people just continued to talk past each other based upon the fact that they had different definitions of what they were implying to be the system every time they used the word system. So just remember, it's a mutual interaction of parts that cause something to maintain its existence, and it has characteristics that aren't contained in any of the individual parts. Now, systems typically, I said there's a character of emergence in that the system exhibits characteristics not found by any of the parts. A system typically has a discernible pattern of behavior over time, which is also an emergent characteristic. As a few examples of systems, one might consider an automobile to be a system intended to transport a person from point A to point B. In terms of a car, there are essential components and non-essential components that cause it to be considered a car. If I take the doors off of the car, it will still take me from point A to point B, though maybe not quite as safely, so that they're not essential characteristics. But if I take the wheels off of the car, it doesn't take me anyplace. So a car, the interaction of all of those pieces that enable it to take me from point A to point B, can be considered a system with an essential characteristic of being able to take me from point A to point B. A clock is a set of interacting components that's able to track or keep time. Though if you take all of the pieces apart and look at them individually, there is no aspect of the clock that has any capability for keeping time. It's simply all of those pieces interacting together. And there's also an aspect of the clock in terms of the way that it interacts and keeps time. By looking at the clock and all of its pieces, you can understand how it works. Though the question about why it keeps time in the way it does cannot be answered unless you consider the clock in a larger context. Not until you consider the clock in the context of the rotation of the Earth can you determine why a clock defines a minute the way it does. So there's a limit to how much you can understand about the characteristics of something simply by studying the thing itself. There are certain aspects that you only understand by considering it in a larger context. Water can be considered a system in terms of a large number of water molecules interacting together to produce a characteristic of wetness, whereas water itself is comprised of two, at room temperature, of two gases, hydrogen and oxygen, neither of which just demonstrate a characteristic of wetness. It's only that when they are combined in a molecular form and you have lots of them together, does it demonstrate a characteristic of wetness. A pile of bricks is generally not considered a system. If you take a brick away, it's still just a pile of bricks. It doesn't actually do anything or enable anything. Though if you happen to take the bricks and pile them up so they held up the corner of a house, you might then consider it not a pile of bricks, but a post. And if you take a brick out of the post, it might fall down. So that If the pile of bricks is configured in such a way that it's actually performing a function, you might then consider it a system. But back to what I said about a system, when it in its interacting state exhibits characteristics not exhibited by any of the components. So with all of those bricks piled up to hold up the corner of the house, it would be considered a system with a utility. And if you take one away, the same thing happens. The same kind of thing with the solar system, in that the interaction between the sun and the planets that keep the planets in their orbit around the sun. And this is an example from Sengi's 1990, the fifth discipline, where there's a desired water level and a current water level, and the difference between those is a gap that I perceive, and that perceived gap causes me to change the faucet position, which changes the water flow. And as the glass fills, the water level gets closer and closer to the desired level, and finally when the glass is full, the gap is 0 and I've turned off the faucet. So this is an interaction between me and an intent with the faucet to fill a glass with water. So these are some examples of systems, and if you look around and look at the way that things exist and interact, and the nature of their properties that result from those interactions, you will find out that to a certain extent practically everything turns out to be a system, and it depends upon how you look at it and think about it. So hope this has been helpful, and we'll see you again in another video. Take care. Bye.